this. 2 cosine delta t, and then minus sine delta t plus cosine square delta t divided by sine delta t. And A bar equal to A plus GC. So A bar, A plus GC, A is here, plus GCG times C. C is minus 1, 0. And I will be able to get A bar equal to minus cosine delta t, sine delta t, and cosine square delta t, and over sine delta t, cosine delta t. And so A bar will be delta t dependent. If you have a different delta t, you have a different A bar. The same thing, if you have different delta t, you have different A. However, it doesn't matter how much delta t you got, your eigenvalue of A will be all equal to 1. Because that is no damping, and that's what happens here. All right, and B, now you look at this, B here, original B, we have only 2 by 1 vector. Now B here, we have 2 by 2 vector because we add a minus G here. So B plus GD, that's minus G, and B plus GD will be 1 plus cosine delta t and cosine square delta t, sine delta t. G will be nothing but 2 cosine delta t, sine delta t, minus, because we have minus sign here, so minus this. Now, if you look at carefully here, now A bar square equal to 0, 2 by 2. That is magic. If you don't believe it, then you can prove it. A bar here, A bar, you look at A bar here, equal to minus cosine delta t and sine delta t and sine delta t cosine square delta t and then cosine delta t. Alright. Then if you have A bar square, now if you look at this, then cosine delta t, sine delta t, minus cosine square delta t over sine delta t, cosine delta t. So you can multiply them together, cosine delta t minus cosine square delta t, sine delta t, and then sine delta t, cosine delta t. Now, if you look at this will be 0. It is only by that. That's cosine square t, and this minus sine cosine square t, so 0. And this is cosine sine 0, and that is times this, okay, cosine cube is 0, and that times that, sine cancel out, cosine square 0. Okay. That means A bar square equal to A bar cube and A bar fourth and so on equal to all 0, 0, 0, 0. Great. So if I choose the G that way, that 2 cosine delta t minus sine delta t and plus cosine delta t and so on, and then I will be able to get A bar just like this, and A bar square equal to 0, 0, 0, 0. Then how can I do that? How do I know that G is like this? Right? But this problem is easy. You can you can just assume G equals G1 and G2, and then I want to be A bar square equals 0, 0, 0, and then try to solve G1 and G2. It's easy. For this problem, that's what I did. You can assume that's equal to 0, right? For this problem, it's really easy to do. For this problem, I can say G equal to G1 and G2. And then I say, okay, my A bar equal to square equal to that A is cosine theta t sine theta t minus sine theta t cosine theta t plus G is equal to G1, G2, and what is C? C is that minus 1 and 0. And I want this square equal to 0, 0, 0, 0. And I can solve G1 and G2 this way. Right? Problem? No? Okay. Now, how do I know is square? I can have a square. Why not it's cube? Why not it's 4? Why is it a square? Alright, that's the question, right? If I can have a square, that would be perfect. Now, now the question is, can we find a G such that A bar equal to 0, 0, 0, 0. Okay? Now A bar square, I say A bar. That's even better, right? If I could do that. No? Yes? No? Is it possible? Oh, it's possible. No? You can just sub in here, see you can find a G1, G2 such that A bar equal to 0. Alright. The same question. Can I find a G such that A bar cube equals 0? Or A bar 4 equals 0, 0. Okay? That's all kind of questions you can have. It's easy to prove that A bar, now it's easy to prove that A bar equal to 0, 0, 0, 0, that's impossible. Well, try this. A bar equal to cosine theta t minus t1, right? And sine theta t, so that's 0, and minus sine theta t minus c2, and then cosine theta t. Can I find a G1, G2 such that equal 0, 0, 0, 0? No, because I have this, I have that, I have no G1 there, I have no G2 there. I can find a G1 such that this 0, but this not. That's not. Okay. Now another question is, after I find my G1, G2 is like this, and G1, G2 like this, and G1, G2, and A plus GC, my G like this, I have a G like this, G like that. That's my G. Like my G. Now the question is, I didn't answer your question here yet, right? We know that's impossible. We know that's impossible. Now what is what? This guy. Now what? The eigenvalues of A bar. Now, A bar. What are the eigenvalues of A bar? We can make it simple. We can have a delta t some value. Delta t equal to, say, delta t equal to pi over 2. Sounds good to you? Yeah. Delta t equal to pi over 2. Then what is A bar? Pi over 2 is 0, right? This is 1. That's 0. This is 0. So what's the eigenvalue of this? A bar. Eigenvalue A bar, how much?